Let's share screen. So we'll continue from this one, but of course we need the context, we need the question itself. So I think I should move it down. Okay, so it says on a planet far, far away on Earth, IQ is, the mean is 115, and the standard deviation is 17. Suppose 15 individuals are randomly chosen. What is the following? So the question will be, if X is a random variable, a child can have and still receive special services dash. What is that? That's not a complete question. Okay, I think that is average. Let me look at the original one. Okay. So this is part of that. So it was B that was solved. So let's paste this here to make that clear. Yeah, so the question will be like, a school offers special services for all children in the bottom 6%. What is the highest IQ score a child? What is the highest school score a child can have and still receive the services? So we're trying to find out the IQ score that marks the boundary for the bottom 6% in that setting, right? So what we need to do is to move this up. So sketching this will always be useful. So maybe sketch our diagram first. Just try to kind of imagine what we are looking at. So if this is your normal distribution, we know that the mean is 115. We know that the standard deviation is 17. Okay. And the question is, what will be the score here if this represents the bottom 6%? Right? That's what so we're trying to look at what is the score at this point here. Okay. If this shaded area represents bottom 6%. Now, of course, 6% is 0.06, right? You convert it to number. So I'm going to see a couple of these questions today using different words. So this one used percentage, but if you recall last class, I did mention that. Okay, so let's write it over here. I did mention that percentage, proportion, right? Area, probability. So whenever you see any of these questions in this section, they are referring to the same thing. They're just referring to the shaded area on the below the curve. Okay, so we are looking for that value that equals this point. And so the quickest way to do this would be to go to the table. See if I can have this up here. Okay, so the quickest way would be to go to the table. So I have it pulled up earlier. Here. So we are looking for, so these are shaded area, right? So we are looking for area that is shaded that covers 6%. And of course, 6% we know is on the first half. So it's supposed to be on the negative side of your Z value, of your Z table, right? So recall that if this is your normal distribution, the middle is 0, and on the right you have positive value, and on the left you have negative values, right? So you know, half of this is 50%. So if somebody is talking about 6%, it should be on the tail, and it should be very low on the tail here. So we expect our Z value to be negative, right? So we're looking for 6%, but then remember also that this is your Z value, and whatever value you have in the middle here are all areas. Okay, I can delete that very easily. Okay, good. They are all areas. So we're going to look for the area that represents 6% in here. So we're looking for 0.06, right? 6% is something as 0.06. So we're looking for that value. So I'll just go down the first column to locate the value close enough. This is 0.06 somewhere here, but this is bigger because what we're looking for is exactly 0.060000, right? So I'm going to go down, excuse me. Okay. So this is still 0.0606, slightly bigger. Okay, so I will always recommend taking the conservative value, this the value slightly less, over the one that's slightly bigger than what you're looking for. So, and of course, this on your homework will mean that, and even on the exam will mean that you might be getting answer that is slightly different from the key, right? I'm going to go back in and review them myself manually and ready for you. Okay, so since this is the closest we could get, 0.0606, it's bigger, we are taking the next closest that is smaller than the value 1. So we are looking at the z value of negative 0.5. We found the answer, the area under 0.06. Okay, so if you have negative 1.5, right? So negative 1.5, and you are adding 0.06, right? That gives you negative 1.56. So you don't just need to do this math. You just know that whatever value you find under the heading column here is your second decimal place. So take the first column as your first decimal place and use whatever value that comes here to your second decimal place. So I should have written just negative 1.5 under 6. So negative 1.56. All right. So that is the z value that is equivalent to 6%. That's what we just found, right? But that is not the question. The question asked you, so I'm going to show this diagram again. So what we just found right now is an answer on this space, right? Let's be more precise. We've just found the z value that is equivalent to this area. So this area here is 6%. We just found the z value that is right here, and we saw that it's negative 1.56. Okay, but the question is asking you the value on this space, on the actual data. So what we want now to do is to use this formula to convert our z value back to this space, and that will be our result of analysis. Okay, all right. So I hope that is happening in some ways. So let's go back to that question. Okay, so now we know that the z value here. So remember, this 115 is an x value. Okay, is an x value in the actual data space, because if this is the main, the equivalent of z value that is 115 will be z of 0, right? So now we have a value here that we're interested in, and we saw that it was a z value of negative 1.56. So all we need to do is to convert that to ordinary number using our formula, of course. So we know that z is equal to data point minus the mean divided by the standard deviation. Okay. So if we plug in here, we know that z is negative 1.56. We don't know the data point, and that is the question here. The question is, what is the IQ that is equivalent to 6%? So that's what we're interested in finding. So we know data, we don't know the data point, but we know that the mean is 115, and we know the standard deviation is 17, right? So we just solve this, right, to get our final answer. So if we solve this, we find that xi will be equal to negative 1.56 times 17, right? Seems like that's what we did. Okay, no problem. Plus 115. So solving that will give you the z value that is in that location. So that data point will be, can you help us with calculator to do this? Negative 1.56 times 17 plus 115.
88.48.
88.48.
Yes.
Okay, thank you. Somebody got something different from that? Anybody got something? Okay, and that makes sense, right? So you expect an answer less than, I'm trying to turn this up. You expect an answer less than 115 because the middle is 115. And you're looking for a number on 6% on the lower end. that distribution. So this will be our answer for that question. Any concern about this one? Okay, so let's go ahead and solve the remaining ones on this. So this one is saying find the interquartile range. Okay, let me pick a different one. So we know that interquartile range, IQR, right? Let's have it here. IQR, the interquartile range, is giving us Q3 minus Q1, right? We saw that maybe first or second week of class. And we know Q3 to be the 75th percentile. So you are looking for the 75th percentile minus the 25th percentile. Okay, so that's what we're looking for. So if you find the value that is on the 75th percentile, subtract the one that is on the 25th percentile. And because they know you're going to do that, so we have question 1, which is our Q1, and we know that Q1 is the 25th percentile. Right? We have question 2, which is our Q3. We know that is 75th percentile. Okay, so now to get the last one, we know what we need to do is to whatever answer we find at the 75th percentile, subtract that of Q1, the one we have on the 25th percentile. So 75th minus 25th. Okay. So the question will be what values are on this percentile? That's all we need to find. So again, so remember this, it's important throughout this section that when somebody is asking for probability, percentage, or percentile, proportion, area, we're just talking about the area under the curve, right? So if we should draw again or sketch our normal distribution, this is the middle, which will be the 50th percentile, right? Maybe 75th percentile might be somewhere here, right? And maybe 25th percentile might be somewhere. So the question is, percentile, percentage of the shaded area, right? So when we say 70 percentile, we're essentially saying, let's start with 25. If this is 25 percentile, we're saying essentially saying 25% of the area, right? So that 25%, of course, converted would be 0.25, right? So you're interested in finding the IQ score, that is on the 25th percentile. So you're looking for the IQ at this point. Okay. So of course, when you have the area, you can use the table to get the Z value because table can only give you the Z value. So we're going to find the Z value that matches this point first, and then we convert it to the actual IQ score, right? Which is in the data space. So let's go ahead to get the Z value for the 25th percentile. We know the 25th percentile, we cover an area 25% to the tail, left tail. We know that will be equivalent to 0.25, right? So if we go to the table, again, you know that 0.25 should be on the left tail. So we expect the Z value to be negative, right? Let me clean up. That's not going to waste time. So we're looking for 25% area that's 0.25. So if you go down the first column again, you have 0.2, 0.27, 0.24 here. So I'm looking for 0.25. So it's like, it's not going to be on this line, just like for the next one. So here we have 0.2514. That is slightly bigger, but on the other side we have 0.2483, which is also slightly smaller. So again, just to be consistent in the class, and there could be a debate about what is conservative in this sense, but just to be consistent, just use the value slightly less. Don't use the one above, right? So that we just have one group. So sometimes it's going to match the answer on the answer key, sometimes it's going to miss it by just maybe the 10 decimal value. Again, I'll go back and grade it manually. So we're going to pick this one here. So let's assume this is the closest we can get to 25%. Then you locate the point where you found it. So if you go horizontally, this is the z value where we found that is negative 0.6, and it is under 8. Okay, that simply means your z value is negative 0.68. Right? So we go with the z value of negative 0.68 back to the question. So we know that at this 25th percentile, the z value that is here is negative 0.68. But the question is, what is the equivalent of negative 0.68 in IQ scores, right? So again, it's just like we did before, you've gotten an answer on this space, but your goal is to present the final answer on this space. So you just got the z value from the table here. So you need to transfer this back to this. And you always use this formula, right? So we'll go back and use that formula. Okay. So over here, we simply do that our z-score, which is, okay, so using z is equal to theta minus the mean divided by standard deviation. I've used simple s here, right? It's something, this is sample standard deviation. So our z value is negative 0.16, which is equal to data point. We don't know, that's what we're looking for. We know that the mean for this question is 115, and the standard deviation is 17, right? So we're going to do that. So we know the mean is 115 and the standard deviation is 17. So just like before, we simply solve for x by multiplying negative 0.16 by 17 and adding 115, right? So again, somebody help us with that.
103.44.
Sorry, say that again.
103.44.
103.44. Okay, so we have 103.44 for the value that is equivalent to the 25th percentile, right? Which is equivalent to Q1. So the z-score we have here is 103.44. Okay, so that gives you the first answer then. So the 25th percentile has the IQ score of 103.4. All right, so we have that in place. We need to get the 75th percentile. So let's go ahead and change the color to make it distinct. So over here, let's try to do the 75th percentile. So again, what we are looking for is the area that is equivalent to the 75th percentile, and that will be the area from this point shaded all the way to the tail, right? All the way to the tail. So remember, we said the table normally shade from whatever point you're starting to the tail. It doesn't matter wherever you start, you just start from there all the way to the tail. So we're looking for the area from this point all the way to the tail. That will be 75% of the total area. And if we convert it, that will give us 0.75. Okay. So, and then don't be careful with this, don't be confused about it. So look at our z value, it's 0 point something. Look at our area, it's also 0 point something. So sometimes they could just be around the same thing, but be focused on which one you are using. So 5% is what we converted and we got 0.75. So when we go to the table, we're going to be looking for the area of 0.75, and then we'll find the z equivalent. So back to the table again, we're looking for 0.75. We know it's going to be on the positive side, right? Because that is 75th percentile. The middle is right here, right? The middle is here. So you are way over here. So it's on the positive side of that. But even if you don't know which side it is, you just look for the numbers. But it will just take you more time if you want to start looking from the negative side. So we're going to go to the positive side because we know the 75th percentile is somewhere around here. So we're looking for 0.75. Go down the first column again to be quicker. This is 0.75. So I'm going to start there, go backward to see if I can find this one out bigger. So go to the next column, the previous one. So here I have 0.75, that is slightly bigger than what I'm looking for. I'm going to step back and take the one that is slightly less, right? So we are going to be using that this one here. So using this value, we found it under Z of 0.6, this time positive, okay, and is under 0.07. So our Z value of interest here will be 0.67. Okay, and this time is positive. Okay, so we're going to pick up that Z value and go to the table to work it out. Go to the question to work it out. So over here, we know that Z value that is equivalent to the 75th percentile is 0.67. Okay, so, but we're interested in the IQ score. That is the answer the question wants. So we're looking for the IQ score. So we're going to do again, Z is equal to your data points minus the mean divided by the standard deviation. So over here, you're going to have Z is 0.67. The data point is what you're looking for. The mean is 115 and the standard deviation is 70. There's normally a way to submit one. Okay, very good. Okay, so we then go ahead and solve this. And if you solve this, you're going to get that your data point will be equal to 0.67 times 17 plus 115. Right? So our data point here will be equal to
126.
126.
0.39.
126.39. Thank you. Anybody getting something different from? You got something. Thank you. So 126.39 is our 75th percentile. So over here, we know that our 75th percentile is equal to 126.39. So now we got Q1, we got Q2, then IQR we know is the difference between the two. We have that formula over here. So let me rewrite it again. Let me use a different color too. Yes, please.
On the green side, where did you put, or where did you get 0.16 times 17 from? Where did that 0.16?
Because when you do the math, it doesn't equal 1.
It's supposed to be 0.68.
Negative 0.68.
Negative 0.68, not negative
So you
0.16.
have
No,
0.68
just each quarter.
up here,
Up
but
there,
then
that's- Negative 0.68 too.
Okay, so let me.
You just wrote it as negative 0.16%.
Oh, okay. So this is what we have, right?
Yes.
Okay, so it was solving one thing and writing a div. Okay, we wrote this one first and then okay. Thank you for catching that. So let's correct that. So this should be negative 0.68. This one should also be negative 0.68. So our answer will be slightly off.
No, I calculated that with negative 0.68.
Oh, okay. Let's get that back there. Okay, so we just need to correct this part. Let's get that. Okay, so we just need to correct here. 68. Yes. Okay, thank you very much. Any other concern or question on this?
I have a question. It doesn't have to do with this problem though.
Okay, so let's be done with this first, okay? Yeah. So we have this value here as 126.39 as over here. So we know that our Q score, our Q, our interquartile range, IQR is equal to Q3 minus Q1, right? Which is the 75th percentile minus the 25th percentile. And so we already know here that 75th percentile is 126.39. I'm going to subtract the 25th percentile, 103.44. 103.44. Can you help us do that? 22.95. 22.95. Anybody getting something different? Okay, so that is what it is here. So you could see that the whole question is revolving around the same thing. Just be comfortable with knowing that all this means the same thing. And so I know where you are on the space at each point in time. That will give you that answer. Any question on this one? Okay, so what's your question?
So if a question asked like whatever the probability of it being over 25%, would you just use the same number as we did for 75 and make it negative?
So negative is still on that. So let's do this very quickly before we go into that. So if I have this shape here and it says 25%, so you have this
Over 25%.
over 25%. So this
Area
is,
would be 75.
yeah, so this is 25%, right? So over 25% it will be the other side, isn't it? So let's say this is still our line, which marks the 25%. Then I will be shading the other side, right? But making it negative will be, so a way to think about that better will be, because so if, for example, I know that this area here is 0.25, which we know, then now automatically I know that this area is 0.75, right? And how do I know that? We can remove 0.25 from 1. We know that the remaining one is 0.75, isn't it? So the same way you're going to work on this. So when you go to the table, if the interest is the point here, right? If the interest is the point here, then if you get a point here, then the other side of, so this one should be the one that is negative, right? So this will be 0, negative 0, whatever the value is, your Z value here will be negative because the middle is here, right? So whatever you get here will be positive, So if I have negative, let me use the one we just saw now. So over here, you see this is negative 0.68. On the opposite side, you see it's positive 0.67, just the rounding off error, right? Because let me create that diagram. I hope that helps too. So 25% below is equivalent to 25% above, right? So whatever value I have here, the -1, because on the left-hand side, the equivalent will be what will be here, and it will be positive, right? So if this place is negative 0.68 as we found, then I expect that this point should be positive 0.68. Does that make sense?
But what about like the rest of the middle?
Yeah, the rest of the middle, so you want to think about it. So the rest of the middle will be the remaining 50%, but that will not help you in this question. Like if this is what you're trying to get, thinking about the middle will not be useful, right? So there are two ways to think about it. I think about it as if I take away 25% here, the remaining must be 75%. That's one way to think about it. Okay. Depending on the question you're asked, right? The other way to think about it is if this is 0.25, whatever value I get here, 0.25 on the right there should have the same value, but the positive version of that value. Right? So, but if the question is not asking you, okay, what is the Z value here, then yeah, if you get this, just remove the negative sign, it's equivalent to what is here. But the question is interested in what is the area here. If I find this area, subtract it from 1, I'll get the area.
Okay.
Okay.
So
All right,
Z
so-
is the area.
Sorry?
Z is the area, right?
Z is the numbers on the horizontal line. Okay, the area will be the percentage or the proportion. But the Z tells you where that area stops. Okay, so let me draw a different diagram to illustrate that very quickly. So if I have this diagram here, okay, let me remove this one. If I have just this line, then this is my Z, just a number line. Right, so this is 0, this is 1, 2, 3 going up, this is -1, -2, -3 going this way. So these are your Z values, right? So this is standardized using the formula we have been working with all today, right? So the X equivalent or the data equivalent of this value, you will have to convert from your work, right? The area is the area under the curve. So what the Z value does is to tell you where that area is. Does that make sense? So if I have a Z value of -2, that is telling me that the area under the curve below -2 is my interest. Okay, all right. So let's go ahead and is there any other question on this one? Okay, so I think I should take the homework questions, and I think one of them repeats actually here. Let's do that before we go to the next topic, which is central limit theorem. Okay. So then we'll go to the homework questions. So you send these ones, we're just going to solve them together. Okay. These are selection from the ones I got. So some of them we've already taken care of, so we're going to be skipping as we go along. So let's look at the first one. It's not a word document. Okay. It's kind of it's not active. Okay, we're going to pick up a new page to solve there, but let's look at the question. Yeah, the first one says the amount of calories customer consumed, the main value is. Okay, so I'm going to open a new Word document and see if I can get an active sheet. Okay, that is better. So let's see if we copy this question and paste it here. Whether it is true. So let's look at the first one. Okay, so we've gone through this, so that shouldn't be a problem, right? Just pick up the mean and standard deviation. So let's start from this one. So I think this answer is correct. It is just this negative sign here. Okay, so be careful with the negative numbers. Okay, so let's look at that first. This question. It says the mean value of calories consumed is this one here, right? The standard deviation is this one here. Okay. One randomly selected customer order. So the question is, what is the probability? And I think this question is good because, see, it asks for probability here, and it's asking you for proportion here. But those two questions are referring to almost the same thing. Right? So let's go ahead and try to take care of this. So the first one says, what is the probability that a customer consumes less than this? And so I'm saying, what is the proportion of customers that consume over this, which is like the question you just asked. So it's a good thing it's occurring, you're going to solve that. So these two questions are asking you about area under the shape, and I think we should solve them side by side to make that point. So for B, our shape should be drawn this way. It's saying, what is the chance that we know that the middle is 2,752? By saying, what is the chance that the customer consumes less than 2610? So 2610 should be less than the middle, right? So we should know that maybe the diagram should be, the line should be somewhere here. Just a sketch, right? And what you are giving here is that this point here is 2610, right? Okay, so and that is to the point about whether C is area or question or number. So you see, these are numbers and these values are in X, like they are just your data points. Okay, so what we are looking for in question B is this area. Question C is the opposite. not exactly. The middle again is 27.52. And the question is saying, what proportion consumes of the customer consumes over 3022 calories? So again, you see 3022 is bigger than the mean. So we know to draw our line somewhere around here, isn't it? But this question is saying over. So we should be shading on the right hand side, above, right? So again, the point here, the number here is 3022. Okay, so these sketches will help. If you can put them in place, it will give you clarity about what you're doing. So what we are looking for right now is probability in question B, and we are looking for proportion in question A. And we've maintained several times here that these two things are the same thing. They're not talking about the area under the curve. Okay, so I'm interested in finding what is this area. That is what gives me the answer to question A. I'm interested in finding what is this area. That's what gives me the answer to question B, question C, sorry, the answer. Even though they are using the word proportion and probability or percentage, they are talking about something. So how do I find that area? We can simply go to the table, right? But before we go to the table, we know that the table doesn't have number in your data form. We want to change the data to Z and then go to the table and find the equivalent of it. So over here, if we use Z here, we're going to have that Z is data point minus the mean divided by standard deviation. And if you solve that, we don't know Z in this case, right? Unlike the previous questions. So here we don't know Z, but we know that our data point is 26. Then in this case, minus the mean, which is 27.52. And we are dividing this by the standard deviation in this question, which is 631. Right? Okay, so somebody help us solve this. And if we go back here, we're doing the same thing. That's something. So here we know Z again is given by the same formula. Using sample standard deviation. So here we don't know Z, we're looking for that. Z here is the data point 2022, and we are looking for, okay, the mean is 27.52. The standard deviation is 631. Okay, so again, someone help us get this back. What do you have?
Negative 0.23.
For this one, negative 0.23, okay? Anybody getting this? Or see? So this is negative 0.23, right? At 0.27. Anybody getting the value for C?
Zero point 0.43.
0.43, thank you. If someone, I mean, you should be doing this so that if we make mistake, we can catch it up, right? Because I'm not calculating now, we're just working off of whatever you give me. So if we get confirmations, that will be better than one person. Okay, so we're taking these two, thank you. We're going to go ahead and look for them. So, and it makes sense that this should be negative because you can see it's below the mean. And again, it makes sense that the Z value for this should be positive because it's above the mean. Okay. So what we're interested in now is the area underneath this, this question. So let's look at the Z value that is area, that covers the area under negative 0.23. So go to the table. Let me just X this out to save me time. Open a new one. Okay, so we're looking for negative 0. So here we have a Z value of negative 0.23. So we're going to look for that on the table. So negative 0, so we should be on the negative space. Negative 0.23. So this is negative 0.2. We're looking for 0.23. We know that should be the fourth one, right? So this is 0, 1, 2, 3. So we are interested in this value here. Negative 0.2. This is 0, 1, 2, 3. We are looking for the Okay, and that is your area. In this case, this is your final answer because area is area. You don't need to convert it. Okay, so we have 0.4090 over here. So this should be the value of this area. 0.40. So the area here, or let's use the word the question is the probability. The probability of getting a value less than 2, and you don't have to write it this way, but probability of getting a value less than 2610, given that the mean is here, is 0.4090. That's what this is telling me. Okay, so then remember probability, area, proportion, they are all the same. Okay. Then let's look at it on this side. This side is saying the Z value for this side is 0.43. Okay, now we're looking for 0.43 is positive, right? So now we go to the positive space. 0.43, 0.4 is right here. So we're looking for 0.43, which will be here. So this is our value. Okay. So our answer here is 0.6664, but it's not our final answer, right? Because remember, this table shows you area to the left tail always, right? So what we have gotten, if we go back to this space, what we have gotten right now is the area from this point, use a different color. So what we've just got is the area on red. That's what we just got using the Z value of 0.43, right? And that value is 0.6664. So the area here on the red, 0.6664. It's not our final answer because that's not what we want. The question says above it, right? So to your question before, if the question is dealing with area, you subtract from 1, okay? But if it is Z, then you want to deal with that differently. So over here, our answer, our required area, which was called proportion in this question, right? So the required proportion, let me go back to that. The required proportion of interest will be 1 minus 0.6664. Okay, and that will give us 0.3336. Thank you. Okay, so be careful with this. So yeah, that is what you do because the question is above, not below, right? The first one is below, the second one is above. So take note of the differences. Any concern or question about this one? So you see, so this could be deceiving, right? The answers are very close somehow, right? But it's just pure chance. Just pure chance that they are that close. So so be careful when you're working this, like have the concept in your mind. Okay, so also the answer we got is slightly different from the key here. The key here says 0.3344, right? Our answer says 0.3334. But if you run this up, you get the same thing. And this is the type I will be correcting manually for you. Right? If you round up to the third decimal place, you get the same value to the third decimal place. But it differs on the fourth decimal place. And that is because these answers were gotten using calculator. So you have a exact value. We are using 4-digit table, so it's cutting off our answer. If you do this and you submit, just shoot me an email if it marks it wrong and you think it's correct, it's close enough. I will go ahead and work it and read it manually for you. Okay. Question on this one? So let's move on. Let's see the next question on that homework and see if we can go to the next topic. I think we should by now. Because so eventually these questions are revolving around the same thing, right? They are kind of doing the same thing. we have already solved this, so let's take this off. We just did that on the homework, right? On my own slide. So we're gonna do this one, of course. And this one will be the same thing as the one we just did. Okay, it's actually the same question, isn't it? Yeah, it's the same question, just a random version of it. Okay, so see that you talk about probability here, see that you talk about proportion here. It's all the same thing, right? Okay, so the person that gave this question know that we've taken care of it already by what we just did. So let's go ahead and solve. And we've also done this one, right? That was the first one we solved today. So this is remaining. We're going to do this. Let's go ahead and do this one. Okay. So let me copy that and transfer it to this side. Okay, so this says the main amount of time it takes for kidney stone to pass through, for a kidney stone to pass is 15 days, and the standard deviation is 6 days. Suppose that one individual is randomly chosen and X represent the time to pass the kidney stone, okay? Run all answers before the capacity. The first question, of course, we're going to skip that. The second one says, find the probability that a randomly selected person with a kidney stone will take longer than 16 days. So this is similar to what we have been doing, but we just do it for illustration as well. Okay. So if you have your distribution drawn, you know that the middle point is 15 days, and you know that the standard deviation is 6. The question is asking you, what is the probability that a randomly selected person takes longer, right? So you pay attention to that, say longer than 16 days. So if 15 is there, maybe 16 is here, it's a sketch, right? But it's saying longer, so which means we're interested in this area above and below, right? Okay, so if that's what you have, you go ahead and convert that to Z and then find the area, right? Remember, the question is asking you for probability, which is the same thing as area that you just shaded, right? So we quickly do that. Our Z value here is given as data minus the mean divided by standard deviation. The Z is what we are looking for in this case. We know that the data point is 16. We know that the mean is 15. The standard deviation is 6. So we solve this very quickly. That will be 1 divided by 6. If we give us 0.1 or something.
Zero 0.166.
0.1667. Again, thank you. Anybody getting something different? So that is your Z value. And so again, you are on the Z space. You want to change it to the number of days. So in terms of days now, you want to change it to area. So in terms of area now, which is the area on top here, but you got a Z value of, so this is your data point. So that 16 is equivalent to Z value of 0.1667. So it's positive, and you can tell it's positive because it's on the right-hand side, right? It's above the mean, so C should be positive. So we'll go ahead and look at this on the table. And you know the table gives us up to 3 digits of C, so we're essentially going to be looking for 1.67, right? So go to the table. 0.17. So this is our 0.1. Let me use a different color. Is our 0.1. We're going to go until we get to 7, right? You get this value here. So this area is 0.5675. 0.5675. So that area, which is 0.5675, is the area here on red, right? Because again, the table 0.5675, the table gives you the area to the left tail always, right? So you remember this and you'll be able to subtract to get the area you need. So the area of interest here will actually be 1 minus 0.5675, and that will give us, anybody got an answer there? So this is marked as correct, so it should be similar, maybe round off error. Normally starting from the third place. What do you have?
14325.
14325, thank you. So if you run to 3 decimal places, you get the same answer as 0.433. So again, it's normally off a little bit. Okay. So that's what we have as your answer to that, because it's talking about area. But then let's look at the second part. The second part says find the minimum number of upper quarter of time to pass the kidney stone, upper quarter, right? So this is just a construction that you need to take care of. Let me change to black. So if I draw this, remember your quartiles, right? The first quartile is 25th. So if I have a horizontal line, this will be 25th percentile. This is 50th percentile, right? This is 75th percentile. So when it says the upper quartile, it's thinking about this space here, right? Because this is the first, this is second, this is third, this is the space we're interested in. Okay. So what is that area there? So if you imagine your diagram that this is 75th percentile, for example, so the question is asking you for the area. If this is the 75th percentile, this point here is the 75th percentile, what do you think will be the value of this area? Anybody? Yeah, so a percentile is talking about area, of course, right? And every percentile starts from 0 on the left going to the right. So when it says 75th percentile, it's like, let's go back to our red. It's like you're shading from here until you get to 25th percentile, you get to the half, middle, which is 50th percentile, until you get to the 75th percentile, right? So if this is 75th percentile, it means this area here is 75%, right? Which is 0.75. It also means this area here must be 25%, isn't it? Because the alternative is what you get from 1, right? So this will be 0. Are you all with me to this point? Okay. So you do this subtraction, you are getting a value that's so your interest here is the z value that is equivalent to this point here. Okay, but because the table doesn't give you the area shaded from the right, the table gives you the area shaded from the left. If you're interested in finding the z value that is equivalent to 75th percentile, that is equivalent to this point here, you're going to be looking for 0.75 in the table, right? Because the area is always shaded from the left tail coming up, okay? So even though your interest is, the number at this point. So we want to get a z value that is at this point. So we're going to use 0.75 on the table. So go to the table. 0.75 of course should be on the positive side. So go down the first column, you come up with 0.78 over there. Let's use a different color, green. So this is 0.75 somewhere here, but it's more. So I'm going to go down to look for something less. This is 0.75 here, right? But it's slightly more, so I'm going to take the conservative value, the one that's slightly less. So I'm looking for this value, and that value was found with 0.6 under 0.07. So my z value of interest here will be 0.67. Okay, so if we come back here on this question, the z value that matches the 75% is 0.67. Okay, that is the z value that is there. But the question is asking you for the minimum number of days, right? It's asking you, it's not asking you the question in the z space, asking you that in the data space. So again, it's like switching from here. We just got the answer here. We just got that this is 0.67. So you want to convert it to the data equivalent, right? So we want to go back there, use our usual formula. So over here, we could tell that the number of days, or the minimum number of days, will be equal to using our Z formula, number of days minus the mean number of days divided by standard deviation of number of days. We got Z over here, so we know Z here is 0.6167. Okay, this is equal to, we are interested in this. We know the mean to be 15 days and the standard deviation to be 6. So we know this is 15 and this is 6, right? So we go ahead and solve this very quickly. We have that. I think I'm writing so boldly. Let's do it over here to keep that space. So we have that XR is equal to 0.67 times 6 plus 15, right? Okay, somebody help us work this out.
19.02.
19, exactly 19.
0.02.
Thank you. So 19.02. Anybody getting something different? Thank you. And so when you have answers like this, what I would say is put it into the system like that. It might grade it wrong, it might grade it right. Some author might say when you're doing computation in statistics and you need number of days, in this case, okay, so if you're conducting this test and you're going to report to the patient how long it will take for the kidney stone to pass, you better say 20, right? You go up to 20 days because it's past 19 days by a fraction. So the report, the better answer will be 20 days. In practical terms, don't run down, right? Because then that will underestimate the number of days. So, but for theoretical purposes for what we are doing, I would say put in 19.2 into the system and see what it comes out. And I'll go back and read the manual. Okay. Any question on this? Okay, so you could see these questions are more or less the same, all of them. They're just going forth and back. So what you want to do in this section is have a proper orientation of what you're doing, right? Know where you are. Am I working on this? Is the question I have, is the answer I have on this space? Do I need to change it to this place? Right? Or am I here? Do I need to find the Z to this place? Like, where do I go? Once you're able to figure that clearly, that will help. And then the question somebody asked earlier, be aware that the Z is just the number on the line. And that when the question says proportion, area, percentage, probability, they're all talking about the area under the curve, right? So if you have this in your mind, and then also be aware that this is a symmetrical distribution. That's the other half is 50%, the other half is 50%. And when you're solving for questions asking you for area, proportion, probability, your answer can never be negative, right? Because surface shaded area can be negative, right? But when you're dealing with a question that had to do with Z value or X data value, then you can get negative. Negative on the Z, but not on the data, right? A negative Z value will imply the data that's equivalent to that Z value is below the mean. And a positive Z value will imply the data that is equivalent to that Z value is above the mean. Okay? So the key thing here is just being aware of where you are in these two charts, these two diagrams. If you do that, then you can think about the question. They are more or less the same thing. If you see everything we've been doing today, we've just been doing the same thing, more or less. Right? And then pay attention to the construction. When it says less than, where is that question? This one, right? When it says less than, right? So that when it says less than and you get an answer in the table shows you less than all the time. That will be your final answer. But when it says more than, then whatever answer you get to the table should be the opposite of what the actual answer should be. Because you're looking for above, not below. But the table will already show you answer below. Okay. All right, so let's quickly use the remaining time to do the next subtopic. It's very straightforward. It's just one concept. So we can do that very quickly and then solve that homework question that have to do with that. So that topic is the sampling distribution and it's all about central limit theory. Okay. So very quickly, what we find is that if you have a sample size more than 30, and I'm trying to illustrate this with a program, a short program I wrote. I hope it works. If it doesn't, we just ignore it. But conceptually, what we are saying here is that if you collect data in real life, and that data, if you plot the histogram, it is normally distributed, then all the computation we are doing in this class so far, you can do it and you have a valid answer. But if that distribution is not normally distributed, if your data point is not normally distributed, and let's say, for example, if I collect data on human features, height, weight, and all that, it's going to be normal. Okay. But if I collect data on other features like, say, income, it won't be normally distributed. It's going to be skewed because definitely on the higher income range, you have fewer people than you have on the median income range. And on the lower income range, you could have, depending on your sample, maybe less or more. Okay, so you might end up having this distribution in the middle. And then if I collect something that, data on something that is targeting a standard, let's say if I collect data on heartbeat, pulse rate, right? I would expect to have fairly kind of normal distribution because everybody's revolving around the same normal heartbeat, most people, except you have each reasons for your own to be higher than. Okay, so but what we are saying by central limit theorem is that it doesn't matter the distribution you started with. If you collect enough samples, enough data points, that is the sampling distribution of that data point will end up being normally distributed at the end. Okay, so I'm going to illustrate this very quickly if the program runs, and then show you. So I have a code included here. Okay, in the second half of this class, or not the second half, maybe the last quarter of this class, we're going to be using SPSS, but the software I want to use now is R, right? It's still just kind of the same thing. So let me hope it runs. If it doesn't, we abandon it. It won't take away from your understanding of the code. So assuming I impute this here and actually run it, and I copy the second part, I'm going to try to do those in parts. So let's copy this part first. Actually, up to this point, this is just kind of preparing the data. I need to explain that as well. So this just created an empty space where our plot is going to be appearing. So if I pick up this part and let me explain what this part is doing. So if you look over here, you see that this code are just the same thing from here going down, they are the same. The only thing that is different is the sample size. So I have M3 here, 10, 15, 20, 30, and 100, right? So let me do this first 3. Okay, so we have sample size of 3, 10, and 15. This data here, this program has generated a data set that is skewed. Okay, so if you plot the histogram, you're going to see that it comes out skewed. Okay, so this is like the first 3. Okay, so you see data is slightly skewed to the right. Okay, but it's the same data set, right? I actually created a pool of 1,000 of it. So the same data set that is being randomly, so somebody is randomly selecting from that. We're going to do chi-square later on in this semester. So the first has just 3 data points selected so many times and plotted out. So you have a skewed data. So you're starting with a skewed data, but when you increase the number of selection you make to 10, you see somehow, the skewness is adjusting. Increase it to 15, it's adjusting more. So let's increase it more to the next set of values there. So let's increase it to let's get it to 20, right? Okay, I'm just going to copy the 3 to save time. We are losing time. So let's run the 3 together. Okay, so over here, the first 2 executed, right? So this is 20, is a little bit closer to 15, but look at 30, the way it is. And if I execute 100, which is the last one, so you see a shape, right? So if you look at all this, you see that the data was skewed initially, but as you progress, the number increases. Close to 30 was when it became somewhat approximately normal. If you continue going higher than 30, you're not really making much difference. So when you're doing a research, there is a minimum number of sample size you need to collect. You start collecting more, you're just wasting time, right? And so what we need to do when we collect the data, we want to transform it to the normal distribution. When it's a normal distribution, then this calculation we are doing so far today, you can do the same calculation. You can calculate probability of people, proportion of people, that, right? Okay, so that's what we are saying. So the central limit theorem is simply saying that if you have a distribution that is skewed initially, if you collect enough data, the sampling distribution of the mean, okay, not the distribution of the data. The distribution of data will remain skewed, but the sampling distribution of the mean will become normal if you collect enough sample, right? So let's see that in actual question there. So very quickly before we go to the question, it's saying now that the formula to calculate the sampling distribution of the mean remain the mean, doesn't change. But the formula to calculate the sampling distribution of the standard deviation, which is now called standard error, will change, right? It will adjust it by accounting for the sample size. And that is why you see the square root of n underneath, okay? So in reality, we just use it to answer questions like this one. So we're gonna solve that question on the homework, and then we'll come back here and discuss this, okay? So let me go to the question on the homework. So this question on the homework. Okay, so I was trying to emphasize. So this is the sampling distribution. I need to copy it on the other space. This is not active. Okay, so the first question is asking you the questions we've been solving so far. The second one is asking you for, it's like this, not so active here. Okay, at least I can write. So the first is asking you for what we've been doing so far, this distribution, this sampling distribution of the data itself is still what we do, which is the mean, right? There are $62 million here. What is that? Okay, 62 is the mean, right? The average production cost, and 22 is the standard deviation. So your data, which is your X, is distributed that way. The mean is 62 million, and the standard deviation is still 22. So that is the answer to that question. But the sampling distribution of the mean. So look at the symbol here. This is the mean, not the data, right? We know that the sampling distribution of the mean is such that the mean is still the mean. Okay, so this will still remain 62. But we know that the standard deviation of that sampling distribution, which is now the standard error, right? So we are looking for this. We know that that is given as the standard deviation divided by the square root of n, accounting for the sample size. Okay, so let's go ahead and do that very quickly. The standard deviation here is 22. And we are dividing this by the standard, the sample size. So what is that? 35, right? 35 randomly selected. So we're going to have square root of 35 here. Can you all help us do that very quickly? 22 divided by square root of 35.
Yeah, 3.7186.
3.7186. Thank you. Anybody got something different? Got something. So that's what will come in here. Okay. So instead of just the standard deviation, we're getting the adjusted one. Okay. And the question C says, we're just going to stop one of them because of time, but this is what we've been doing all through today. So it doesn't change, right? Find for a single randomly selected movie, find the probability that the movie's production cost is between this and this. A single randomly selected movie. So this question is working on this distribution. This and this are the same. Okay, so that when you're going to solve this, you will see use the same formula that we used before. Your Z will be defined as your data points minus the mean divided by the standard deviation. That is for question C. But for question D, it says, for the group of 35 movies, find the probability that the average production cost is between. So the question is technically the same thing. But this one is talking about what will be the probability if you select one person. And this one is saying, what is the probability if you have 35 different movies? What is the average cost? So this is dealing with, let me use a different color. This is dealing with, is concerned with this distribution. So this question is related to this distribution. So that here, your Z value that you're going to use for question D, your Z value will be X bar minus, beta minus the mean. But in place of the standard deviation, you're going to use this formula. So at the denominator, instead of just using standard deviation, you're going to use standard deviation divided by square root of n. Because you are dealing with 35 movies together, what is the chance that, so like, if I say, what is the chance that if I pick an individual, the person has a particular score, talking about one individual, okay, let's use height, for example. What is the chance that I pick an individual from this class, the height is above 5.3 feet, right? It's different from the question, what is the chance that if I select 5 people from this class, the average of their height is above 5.3 feet? These are two different questions, right? So the first one is dealing with B here saying if I select one individual, what is the probability that, C rather, if I select one movie, what is the chance that the cost will fall between 50 and 60? The second one is saying if I select 35 movies, what is the chance that the average is above that? Okay. So whenever you hear this structure, the second question, just know that you're dealing with central limit theory. That the only thing that needs to change in your formula is the denominator. Every other thing is the same. And how you solve the question here is exactly the same way we'll be solving it since morning, right? Same Z, the same table, the same area, everything is the same. The only thing you need to adjust is just the standard deviation, right? So to round up, for question C, you have a distribution like this, and the question is saying if the mean is 62, right? The mean is 62. What is the probability that somebody gets selected to be here? Maybe 60 and 56. So you're looking for this area. This one is saying, so the Z value you'll be using, the standard deviation you'll be using will be this one. This one is saying the same thing. It's already the same thing, right? That's, again, the middle is 62, and you're looking for that area, 50, 60, 60, okay? You're looking for this space here. It's the same question. The only thing is that if you're going to solve this, the standard deviation you'll be using will be standard deviation adjusted, right? So that's what you put in instead of using just your standard deviation. You're going to be using the adjusted. But the way you solve this question is the way you solve every other one.
How do you solve E? Because I keep guessing on that homework because it's not really.
For part D is the assumption of normal necessary for part D. Okay, so we're out of time. Let's talk about this next class. So what will happen is on your
the test.
Yeah, I know. On your test, I'm going to exclude unit 6. Okay, because I talked through it very quickly. I don't want you to be responsible for that, so I didn't take time. So you focus on unit 1 to 5. Okay, I'm going to send you an email on that. Please come and mark on the attendance. So next class, we answer your question, okay?
So with 5,
Yes.
is unit 5 to do tonight, so.
Yeah.
62.
Yeah, okay. So you need to kind of focus on this.
Our unit 6.
I will just forget about that since we didn't cover it. Okay. Yeah. So unit 6 is out of your meeting entirely. Okay.
But what about the homework? Is it still due tomorrow night?
I will just suspend it.
I'm still kind of confused.